Thank you, everyone, for coming. My name's Jason Grillo. I'm the event director for AirMiners. Glad to see so many people coming to our first of what will be two ocean events. Today's going to be focused on pathways and methods, setting the stage for frameworks of how to think about ocean carbon dioxide removal. Future event will focus a little bit more on entrepreneurships and models for implementation. So today we're setting the context and getting some of the principles set up. In the future, we're going to get a little bit more, a future event, we're going to get a little bit more specific. A couple of other items before I hand it over to our moderator, Brad Ack. First, please stay on mute. For those of you who have never been to an AirMiners event, this is a Zoom meeting, not a Zoom webinar. So please be on mute for the entire time, for the entire 60 minutes. We are going to track all of your questions in the Zoom chat as you ask them and pass them along to our moderator and panelists. Finally, again, it's great to see so many faces here, so many new faces as well. One aspect of ocean CDR in particular that the panelists and I discussed, speakers and I discussed when we were aligning on how to have the event today was that there's a great need for diversity of opinion, of backgrounds, different contexts, different opinions in ocean CDR specifically, that in order for ocean carbon dioxide removal to meet its full potential for reducing carbon in the atmosphere, there needs to be a greater diversity of voices, that there need to be more people included in the conversation here, people who might not have otherwise have had a voice in the past. So with that in mind, we're going to share several links of how to learn more about ocean CDR and places to go to once we have concluded our event today. So we're going to do 60 minutes of panel discussion at the top of the hour. I'll be back and we'll do optional breakout rooms afterwards. But for now, I'm going to cede the stage to Brad Ack, our moderator, to take it from here. Thanks, Brad.
You bet. Thanks, Jason. And good afternoon, morning, evening, everybody. Great to see all these faces and little boxes on my screen. My name is Brad Ack. I'm the executive director of an organization called Ocean Visions, which is a consortium of academic and research institutions working in partnership with a variety of different sectors from civil society to accelerate ocean solutions. And ocean-based climate solutions is at the very top of our agenda, and we'll have a chance to talk a little bit more about that as we go on. I'm going to present some framing comments to why CDR and why ocean CDR. Some of that is going to be very familiar to some of you, but maybe not all of you. And then I'm going to turn the stage over to David Koek, my colleague, who's going to actually talk in more detail about some of the specific ocean-based CDR pathways that I know a lot of people have interest in. And then we're going to hear from panelists Brad Warren and Will Burns about particular aspects of the ocean CDR equation that merit more attention and focus. And we'll leave a lot of time for conversation. So I've had a 30-year career trying to protect and maintain a living environment. And over the 30 years, I've seen that goal get ever farther away, not closer. So it's a very unsatisfying career to date so far. Climate has been the overwhelming driver. Atmospheric concentrations of CO2 have been the overwhelming driver of loss of most of the things that I've worked on to protect and maintain. And so I've come to the conclusion that there can be no higher order of conservation work than to reverse the climate crisis. And ocean-based carbon dioxide removal is not just a CDR and a climate issue. It is actually also very likely to be an ocean conservation, ocean protection action. I want to make that point again. Ocean CDR is not just about climate, it's equally as much about protecting the ocean. So a couple of framing comments. We're in the midst of the climate crisis now. I think Probably most of us on this call know that. It's not something for the future. We're clearly in the midst of seeing dramatic changes across many of the systems on the planet. Most of the model's predictions of change and impact are arriving at a much faster pace and at lower concentrations of atmospheric CO2 than what was predicted. There's almost no model that is overestimating at this point the amount of impacts that we're seeing. The oceans are, I think, without question, the most heavily impacted natural system on the planet from this climate disruption to date through two primary pathways: heating and acidification, direct CO2 absorption. Ocean heating is literally mind-boggling. Over the last 25 years, the oceans are calculated to have absorbed somewhere between 9 and 13 zettajoules of heat energy. And you can Google that afterwards, but that, I had to go and do the math. It basically translates to around 5 to 6 Hiroshima bomb equivalents of heat energy going into the ocean per second, every second, every day. That is causing all sorts of incredible damage, from sea levels rising faster than forecast, coral reefs on the precipice of extinction, much more powerful storms, increased melting of sea ice, changes to ocean currents, poleward migration of species, interrupted mixing between deeper levels and upper levels of the ocean, which has enormous impacts, and deoxygenation. So the effects on the ocean from the climate crisis are outstandingly large. They're absolutely almost impossible to wrap your mind around, which is why we have done such a poor job to date of wrapping our mind around this. And why the current climate agenda is totally inadequate for the oceans, in my humble opinion. A 1.5 degree target, or somewhere around 450 parts per million of CO2 in the atmosphere, is very likely a death sentence for many parts of the ocean. And that in turn means for many parts of civil and human society, because we literally cannot survive on the planet well without healthy functioning oceans. So we need to reframe the climate agenda away from working towards a goal of 1.5 degrees or 2 degrees, which are significantly worse off tomorrow than we are today, and listen to the words of James Hansen. Sorry, somebody just muted there. That we need to be targeting a CO2 level of around 350 parts per million of CO2 or less in the atmosphere. And I think if you actually take into account ocean indicators, it's probably going to have to be significantly less, somewhere around 300. So, and we're going to have to get that CO2 reduction, not just from the air, but from the sea. And this is something that it took me a while to wrap my mind around, right? As we pull CO2 out of the air, the sea, which has absorbed a significant portion of that anthropogenic CO2, is going to respire that CO2 back into the atmosphere. So we have to work on both fronts at the same time if we're going to be successful here. The good news in this equation, if there is any, is that the ocean presents some enormous opportunities to accomplish this enormous task. Given that they are 70% of the planet, and volumetrically even more than that in terms of the living space, and because they already play such an enormous role in carbon capture and sequestration, both biologically and geologically, we can learn from these processes and seek to mimic and enhance them and build upon them in order to get to these lofty and ambitious goals of reducing overall atmospheric greenhouse gas concentrations. To do this, we're going to need greatly intensified research, development, testing, and ultimately deployment. We are at zero right now in ocean-based carbon dioxide removal in terms of actual significant deployment at scale of any particular approach. The good news is we've got a lot of running room in front of us, a tremendous amount of running room. We need to 100x and 1000x the amount of effort that's going into this space right now. And so I'm really excited to see all the people on this call because it shows that there is some strong interest here. The RD&D efforts that we are going to need have to be accompanied by rigorous and transparent monitoring and evaluation frameworks so that we understand all environmental and socioeconomic impacts. We have to build social and political license for this field. It will be one of the most critical things we do. And obviously, we're going to need sound governance and legal frameworks. And so we have a great group of panelists to talk more about all of these different aspects. And I'm going to start with Dave Koek, who is going to give us an overview of what these different pathways might look like. So, Dave, over to you.
It's great to see so much interest today, and I'm really excited to have a chance to speak with you all. My name is David Koek. I'm the Science Director for Ocean Visions, the same organization that Brad discussed earlier. And you know, I just want to start by saying that, and I think this is probably not a surprise to most of you on the call, but just to really reinforce this point, look, you know, we need 100 to 1,000 gigaton scale carbon dioxide removal by the end of the 21st century to stabilize the planet at warmer temperatures than we're at now. You know, we're somewhere between a degree and 1.1 degrees of total warming. And, you know, these 100 to 1,000 gigaton scale targets are to stabilize warming at 1.5 degrees. And anyone who's lived in the Gulf Coast or in California, especially this past summer, I would say is not excited about a 1.5 degree world. I know I'm certainly not. And so when we start to think about carbon cycling on this planet, we have to think about the oceans. And the reason is that the oceans by far and away are the largest reservoir of carbon on this planet. So they're the biggest and most outsized lever in thinking about the distribution of carbon between the land, the atmosphere, and the oceans. And so we have to, you know, again, we have to be thinking about what it is that can facilitate the invasion of atmospheric carbon dioxide into the ocean in an environmentally responsible manner. But if we can do that, the oceans can play a massive role in cleaning up our atmosphere. And that's really for two reasons. You know, the first is that when we think about scalability, we have to remember that we live on a blue planet, not a green planet. You know, the surface of the ocean covers about 71% of the planet. So if we can find technologies that work, there's massive potential for scalability. And there's massive potential for scalability that doesn't compete with terrestrial resources or terrestrial needs like fresh water, nutrients, competition in space for agriculture, et cetera. So, you know, that's the first reason. And then there's the second reason that, you know, there's this natural geologic cycle, which is what allows the oceans to safely sequester the carbon dioxide in seawater. And so, you know, the oceans already store this massive amount of carbon dioxide in seawater, and there's the potential to continue that process, to accelerate it. And that's what I want to talk about with you in these next few slides. I want to share with you some of the potential options for doing so. And, you know, before I do that, I just want to say I took a moment to sort of scan through the roster of folks who are on this call. And I'm very well aware that we have some experts in the room. I'm very well aware that we have some folks who have really detailed knowledge about some of the specific pathways. But what I want to speak about generally are some of the, I want to sort of speak at a higher level. I want to speak about the general approaches that we might use to think about taking carbon dioxide out of the atmosphere and storing it in the oceans, or capturing carbon dioxide from seawater, recognizing that we're not going to dive into really great detail, but I just want to give people this sort of overarching framework for the rest of the presentation, or for the rest of the panel. So perhaps the most popular option that people are talking about right now is dramatically expanding ocean productivity by scaling large-scale kelp or seaweed or macroalgae farms in the open ocean. So, you know, people are talking about doing this really at sort of industrial scale. Think hundreds to thousands of square kilometers in the open ocean. And there's a sort of a nascent RD&D program, at least in the US, to support some of this work. The ARPA-E Mariner program has been looking at, whether or not macroalgal cultivation can serve as a significant source of biofuel to support light-duty vehicles in the US. And analogously, there's an interest in growing this at large scale, and then not just using that seaweed for fuel, but actually for the purposes of carbon dioxide removal, we need to sequester that carbon dioxide. So can we grow it at industrial scales and sequester it? Some folks are talking about growing it at industrial scales and then sinking it to the deep ocean. Others are thinking about bringing it on shore and potentially refining it for high value bioproducts, and then sequestering the rest of the carbon via a whole series of different processes, including bioenergy with carbon capture and storage, or through pyrolysis. But the key point is that, this is really harnessing the power of photosynthesis to take up a massive amount of carbon dioxide. So you can sort of think of this as the ocean's equivalent to the sort of Trillion Trees initiative. Can we harness the power of the oceans and harness the power of photosynthesis to not only grow and fix carbon dioxide in the biomass of seaweed, but then also sequester that on timescales that would that really pull it out of the atmosphere for long periods of time. The second option is really related to this. It's really thinking about, instead of growing seaweed, growing phytoplankton and then sequestering that in the deep ocean. And there's a variety of proposals to do this, but they all basically require nutrients. They require fertilizers, just like how we would grow our lawns. We need fertilizer for our lawn. So some folks are talking about running sort of massive scale cargo ships and then distributing nutrients where they're needed across the surface of the ocean. Others are talking about pumping new nutrients up from depth. But of course, when you do that, you'll also end up liberating some extra carbon dioxide. So that needs to be accounted for in a sort of life cycle analysis. And then of course, with phytoplankton, once you grow it, once you capture the carbon dioxide in the phytoplankton cells, then the same problem exists with seaweed. You need to sequester that. You need to get it away from being able to be decomposed and returned to the atmosphere on short time scales. The second big branch of options that people think about are broadly called ocean alkalinization or ocean alkalinity enhancement. And this is basically accelerating the geologic process that allows the ocean to store so much carbon dioxide in it to begin with. So these are basically engineered processes that essentially increase the ocean's appetite for carbon dioxide. There's a whole variety of pathways. Some of you might be familiar with things like coastal enhanced weathering or enhanced rock weathering, accelerated weathering of limestone. I don't want to get into the details of these too much, but just to say that, it generally involves either crushing up carbonate or silicate rocks or producing reactive alkaline minerals and then distributing them on the surface of the ocean. And again, that sort of is increasing the ocean's appetite or capacity to suck up carbon dioxide. The third pathway, or the third sort of domain that I want to talk about is highly related to ocean alkalinization. And this is basically using tools and principles from chemistry, and especially electrochemistry, to forcibly remove carbon dioxide from seawater. So there are a variety of pathways that have been proposed and demoed sort of at benchtop scales that allow you to use techniques and principles from electrochemistry to actually strip seawater into a portion that's more acidic and a portion that's more basic. And then you can do a variety of things to capture the carbon dioxide from the seawater, then return the carbon dioxide depleted seawater back to the ocean where it can absorb more carbon dioxide from the atmosphere. So there's pathways that can take that carbon dioxide out of the acidic portion. There are also pathways that can take carbon out of the basic portion. All of these are still basically at benchtop scale. There haven't been any sort of large scale field trials. And the last note that I want to leave you with is that some of you may have heard about coastal blue carbon, things like, these are all the coastal vegetated habitats. So places like seagrass meadows, mangroves, salt marshes, etc. These are really dense stocks of carbon. That is, you know, per unit area, they cover lots of carbon. But when you actually look at the flux rates, that is the rates of carbon uptake that are needed to generate, multi-gigaton scale per year carbon dioxide removal, we're just not going to get to it with coastal blue carbon. So we want to protect these ecosystems. They already store a lot of carbon, and they offer lots of other ecosystem goods and services, things like water quality enhancement, nurseries for shellfish and finfish, erosion protection, etc. But, you know, I like to say that these are necessary but not sufficient to reach the gigaton scale carbon dioxide removal that's necessary. So with that, I'll stop and turn it back over to Brad.
Thank you, Dave. Excellent. And we will, I see some questions have come in, but we're going to finish with our panel and then turn to questions. So please be patient. So, you know, Dave laid out that there's a lot of technical issues associated with scaling up, beginning to scale up potential ocean-based CDR, but clearly there's also human issues as well. Social and political license issues around anything in the oceans have always been challenging, and governance issues in our oceans with the framework and patchwork of jurisdictions and authorities also is difficult. So we're going to hear from a couple people in sequence here to talk about each of these briefly from their perspective. I'm going to start with Brad Warren, who is running the Global Ocean Health Initiative, and I'm going to let him introduce himself and just make some comments about how you, Brad, see the pathways for ocean CDR. You are on mute also.
There we go. Thanks for putting this together. It's exciting to see all the interest in this. It's an important subject, and I would say most of us are late to the party, myself included. In about 2012, when we were working a lot on ocean acidification and pulled together the proposal for the Blue Ribbon Panel on Ocean Acidification in Washington State, one of the things that we did was to put together a paper, and it's now, I think, sadly out of date and perhaps too optimistic in some respects, that suggested that there might be things to do to remediate and sweeten the waters. A lot more has been learned since then. Many of the options have been constrained more closely. And a lot more interest has developed in the field, not only in the dimension of altering ocean biogeochemistry back toward what it once was, but also, I think, the larger problem of sequestration. As you've heard, the ocean is kind of the big pump, and it's going to get used to help deal with this problem. And it maybe the best thing to say about this moment in history, I think Brad nailed it, it's dire, but the best thing about it is that humans are good at meeting emergencies. We kind of stink at the frog in the boiling water problem, and we're great at crisis response, for better or worse. I mean, that's not the best way to meet all problems, but it's what we're doing. By having allowed things to get so bad for so long, having really failed to reduce emissions, we've created an urgent need to develop a new kind of solution beyond emission reduction. IPCC made it really clear we need to do removal, as you've heard. And that's, the ocean's going to get drawn into that. And in some ways already is being drawn into that. And we're in the early part of that. As a sort of longtime observer and sort of think tank participant in dealing with ocean management and conservation issues, one of the things that we've noticed is that, and this is not meant to be an insult, it could be taken that way, but most of us who look at the ocean from the shore kind of have this unconscious colonial approach to it. We go, oh, look, it's empty. It's a wilderness. Let's fill it with whatever we think is the solution to the world's problems. And actually, there are incumbent users and residents. There are people who have legal rights, particularly tribes have treaty rights. There are folks who've been the neighbors on the water for centuries. And in the green worlds, the sort of environmentally oriented development approach that people imagine, there is, I think, a need to recognize the urgency. Yes, that's absolutely real. This urgency cannot be wished away. And a very urgent need to not just pursue huckledebuck, I've got the answer, I'm going to tell you what to do. But what you heard Brad talk about, the need for governance and transparency and inclusiveness. Dave talked about that too. And I mean, I think it's Jason as well. We have a narrow group of us who think we have solutions, frankly. And that approach has been tried before, and it tends to blow up. It tends to bog itself down in conflicts that don't need to happen. And our hope is that we can approach the folks on the waterfront with the idea that they, and there are many of them, maybe worldwide 1 billion or more people who depend on the ocean for food and livelihood. 3 billion according to FAO who get their food from it, an important part of their food. These folks need to be dealt in. And for many of them, and I know some of you really understand this, the piece that people are going to want is an answer to problems that are different from the ones we have in mind. They're not thinking about carbon, but they're thinking about things we might be able to help them with. And there are a variety of jobs and energy benefits and local economic development objectives and things that people are urgently concerned about we might be able to play a role in. I think we as a community need to meet them where they are and start thinking about what multi-benefit programs can we create that help them meet their own objectives while also meeting carbon objectives. And I'll stop there.
Thanks, Brad. I think we lost your video too. At least I did.
I saw something. I'm not sure what went on there. Let me try.
All right. Thank you for the comments. And last, but certainly not least, the legal issues are definitely really challenging as they are on land, but maybe more so and less understood by most people in the ocean CDR space, but not Will Burns, who understands them better than most. So Will, I would love to hear your thoughts on some of the governance and legal challenges and issues that and opportunities that we have ahead here.
Thank you very much, Brad, and thank you everyone for attending. One of the things I want to say at the outset about the legal and regulatory landscape when it comes to ocean-based CDR is when I engage with scientists and entrepreneurs in this topic, often I get a lot of groans and eye rolling, and they view this as a really undesirable thing. And want to say a couple of things at the outset about that, the idea of legal regulation. First of all, it's inevitable. You can't get away from it, right? And those who do, in my mind, do a disservice to the carbon dioxide removal community. For example, there was a rogue scientist in the last decade that decided to engage in one of these kinds of ocean CDR experiments called ocean iron fertilization, and essentially said, I'm going to do it without permits. I'm going to do it right outside of the purview of regulation and defy you to do anything about it. And in my opinion, it created a backlash against this kind of research that can besmirch those of good faith who seek to proceed to do this. So it's not a good idea to do that. The more uplifting part of this is that a good regulatory legal environment can facilitate this kind of research and facilitate deployment. When you put rules in place, people tend to trust you more as long as you're adhering to those rules. And that's going to include key actors in the global south, for example, who are going to be suspicious that the global north is just trying to get out of reducing their emissions by quick fixes, right? Legal regulations, especially those that they help craft, will cut through some of that. Also, if you're going to develop voluntary carbon markets, a really good regulatory system that includes rigorous assessment is going to help further those markets in a way that the private sector might not be able to do. So don't always consider the law and regulation to be your enemy. There have been, at the international level, a number of initiatives to already regulate carbon dioxide removal, including in the oceans. As I said, in the last decade, there was a series of experiments on ocean iron fertilization, about 13 of them, and 2 international treaty regimes decided to mobilize to react to that. One was something called the London Dumping Convention, a treaty that focuses on placing of materials in the oceans that could have deleterious impacts. That convention passed a resolution that said that that this kind of work doesn't constitute dumping. Okay, that's something to be emphasized. That's good news, because often the London Dumping Convention is portrayed as an enemy of carbon dioxide removal, and I don't think that's true. The second thing they said, though, was that because we don't have governance in place at this point and we don't know a lot about the science, if you're going to engage in at least ocean iron fertilization experiments, it has to be at a small scale, right? And that's reminiscent of the precautionary principle that we apply at international law. They also, in this resolution, indicated that there should be no commercial motives at this point. You shouldn't be trying to engage in this to sell carbon credits. And then finally, they said it has to be subject to a rigorous risk assessment framework, and they subsequently formulated that assessment framework. So if you're going to engage in this, your national government is to engage in that risk assessment framework. Subsequent to that, a treaty that's growing out of the London Dumping Convention, its successor agreement called the London Protocol, actually passed an amendment to that protocol, which would be legally binding as opposed to these resolutions that are passed on the parties. And it, again, expanded the purview beyond just ocean iron fertilization and said you could regulate other forms of marine-based geoengineering. Again, small scale at the outset, at least, subject to risk assessment. But again, indicating that the reason that has to be done now is that we don't know enough about this to proceed at a large scale. Some NGOs have sought to portray this as a moratorium on marine geoengineering. It is assuredly not. That regime has imposed moratoriums before on things that they just didn't want to happen ever, right? And they didn't do that in this case, right? They set up a cautious, iterative framework, and I think that's the right way to proceed. The second international regime that's looked at these issues is the Convention on Biological Diversity, which protects biodiversity interests, including in the oceans. The resolution that they have passed is very similar to the one that was passed by the London Convention. Small scale at the outset, no commercial motivations, and risk assessment, with a focus on the potential impacts on biodiversity. There are other international regimes that would be pertinent in the future if we were to do these things at large scale, any of the things that David had outlined. For example, the United Nations Convention on the Law of the Sea, which has been denominated the Constitution of the Oceans. The Law of the Sea provides for that if these experiments or deployment were to occur in coastal areas inside of 200 miles of a coastal area, it would be regulated predominantly by that coastal state. It also provides for the right to research subject to the coastal state's regulations. On the open oceans, it provides for a kind of a capacious definition of research and indicates that research can proceed, but it also emphasizes that if there is harm that occurs to the interests of other parties, it can give rise to liability, right? Either in terms of research or in terms of deploying these technologies. There's other regimes that would also be pertinent. Regional fisheries organizations, if there would be potential impacts on fisheries production, either positive or negative from these activities, could intervene. Marine pollution conventions, many of which exist at the coastal level, and other regimes of that nature. The Paris Agreement could also be pertinent in the long term. Paris provides that the pledges that the countries make are to include mitigation measures. And mitigation includes not only reducing emissions, but also enhancing sinks, things that store carbon dioxide. So it seems clear that in the future, parties could fulfill some of their obligations to meet the Paris Agreement by enhancing sinks in the world's oceans through some of the techniques that David talked about. Also, Article 6 talks about using market-based mechanisms to try to reduce emissions. And so to the extent that some of these might generate carbon offsets, for example, this could be facilitated by the use of the market mechanisms under Article 6 and the rules that have been established. And then finally, Paris talks about things that would have to be considered in terms of how these things were rolled out. It indicates that response measures are subject to human rights considerations, which could be pertinent in terms of some of these, protection of ocean integrity, biodiversity, and the interests of indigenous peoples, all of which might be pertinent in terms of some of the approaches we're talking about, and that's consistent with what Brad has told us about in terms of considering the interests of communities. And the last thing I'll say is if some of these activities occur in coastal areas, for example, like coastal enhanced weathering or within the exclusive economic zones of countries, then there'll be an array of domestic laws that might be pertinent. For example, if this were done in the United States, laws such as the Coastal Zoning Management Act or the Clean Water Act could be pertinent. If you were using industrial waste materials for enhanced weathering, for example, the Resource and Conservation Recovery Act, the so-called Superfund legislation would be pertinent. So one would have to be looking at those regulations as well as potential state regulations and even local regulations, especially if it were beach-based approaches. So all of those should be looked at and looked at in advance before one considers these in the future. Thank you.
Thank you, Will. That's a lot to chew on. And we have a lot of questions and comments in the chat to chew on. Sort of hard to sort through them quickly, but I'm going to start. There's a number sort of around the permanent scale and permanence of carbon sequestration pathways in the oceans. And Dave, I'm going to ask you just to address that. There seems to be some question about whether the numbers really stack up. Can we really get the kind of gigaton scale of permanent 1,000-year plus sequestration in the oceans, and what does that look like?
Yeah, thanks, Brad. Let's start talking about sort of seaweed and macroalgae, because I think that's one of the areas where this question comes up most frequently. So, the basic principle of growing macroalgae and sinking it quickly has the potential to store the fixed carbon dioxide on timescales of hundreds to thousands of years quite easily. All you need to basically do is choose a location that's appropriate for sinking so that you can get it basically below the thermocline or below the pycnocline, which is the density transition from the well-mixed surface layer that occupies the upper 100 or 200 meters of the surface ocean into the deep ocean. And then to basically make sure that that's an area of the deep ocean that doesn't upwell very frequently, or doesn't upwell very shortly thereafter. So as an example, you might not want to do this along the California coast if you were concerned about permanence, where there's just due to the frequency of upwelling along the California coast. But once you get it below there, there are many, many places across the global deep ocean where you can effectively consider it sequestered on the timescale of hundreds to thousands of years. In terms of ocean alkalinization, almost all of those pathways result in the production of bicarbonate in the ocean. And the reason that the oceans are able to store so much carbon, so much total carbon to begin with, is because most of it is stored as bicarbonate, which is not capable of gaseous exchange with the atmosphere. So the timescale, or the residence time, the turnover time of bicarbonate in the ocean, is on the order, I think, of like 10,000 years. I might be wrong on the number there, but it's clearly above the 100 to 1,000 year timescale that we're thinking about when we're starting to think about these questions of permanence. So if you can get it in the oceans as bicarbonate, you can basically safely consider it sequestered.
Great, thank you. That was super clear and helpful. There's also, you know, a set of questions here around the how do you build the coalition that's going to be needed? Because, you know, and it seems to me that there is a natural coalition that is just waiting to be energized here. And I think back to 2016 and the final, you know, weeks and months of the negotiations over Paris, and the really outsized performance of the small island developing states in getting the final agreement to be closer to 1.5 than 2, because their very survival depends on it. And if you take some of the comments I made at the beginning, there's a number of communities whose survival depends on this, yet we are not doing, or have not yet done, very much of a job of building that coalition. So Brad, Warren, I'd just like to hear what you think about what would be, from your perspective, some of the ways that we could do better at building a broad-based coalition here that could move this forward.
It's a great question, and if I knew the answer, I'd you know, announce it here. It's a question we're spending a lot of time thinking about. As a starting point, we think that the folks who already depend on the ocean and use it need to be part of this conversation. Some of them may want to be involved in a variety of roles in building a future that they far prefer to the future of no action, for example. Many of them simply aren't concerned about carbon. It's not on the urgent list for them. It's an abstraction. You know, we're a pack of carbon nerds. We think it's really important. They're worried about getting their kids fed and preventing their home from flooding and things like that. We are going to have to learn to meet them where they are. So a fundamental piece of our approach to this is to do deep listening first, and go to these communities and find out what are they concerned about now? What are the issues they really want to move on? How can we explore the potential fit between this kind of approach and what it might conceivably bring to them that they care about? And then, you know, can you build honestly real jobs for people, not the kind that, you know, frankly, too often promoters of one either environmental or industrial vision or another will come in and say, we're going to give you lots of great jobs. And it's often hot air. These are not jobs. And an awful lot of this is exaggerated. And people know when they're, you know, they have truth meters, and they can really hold you up if you lie to them. And there's been an awful lot of lying going on to these people, and they're fed up with it. You know, they don't necessarily vote the way I wish they would. And a lot of that has to do with how often they feel they've been lied to.
You know, it's an interesting point, because in many ways, I feel like our entire climate agenda is a bit of a lie. And the lie, in my opinion, in my view, is that 1.5, working towards a 1.5 degree target, is going to guarantee anybody any measure of safety, much less coastal communities and people who depend on the ocean. They're going to be at the very front lines, and already are, of when that lie becomes obvious. And it's not a lie in the sense that it's intentional, but it's a lie in the sense that it's not really backed very much by science, and the climate scientists don't even say it. why are we having such a hard time really permeating with the message that we need an agenda that actually strives towards safety, and that there's the math is unequivocal at this point on CDR. It's just a question of where we get it, but it's unlikely that 9 billion humans are going to survive on the planet in any form of life that we would deem acceptable without massive quantities of CDR. Will, what's your thoughts on that?
Yeah, I think that's absolutely right. We're going to need a massive scaling up of these kind of approaches, and it's a reality that the climate community just hasn't been willing to confront to date. There's a lot of magical thinking that we are going to decarbonize the world's economy within a decade, and that'll hold us below 2 degrees, 1.5 degrees, and it doesn't reflect reality. It also doesn't reflect the fact that there are many sectors that will be extremely difficult to decarbonize, and as a consequence, we're going to need to balance that out with carbon removal on a very large scale. But it's a story that still needs to be told, and people convinced that it has to be part of the portfolio.
Thanks. There's another question here. I want to turn to you, Dave, about what we call co-benefits, right? Which I sort of led with in my opening, that ocean-based CDR might well be ocean conservation also, depending on how we do it. Can you speak to some of the co-benefits from some of the different CDR pathways that you've looked at?
Yeah, certainly. Thanks, Brad. Perhaps the most obvious and apparent co-benefit is localized reductions in ocean acidification. So ocean acidification is sort of the other side of the coin of the climate problem. And, the oceans are doing us a huge favor by absorbing that carbon dioxide, limiting the rate of warming by limiting the amount of carbon dioxide that ends up in the atmosphere, but it comes at this cost of acidifying the ocean. So when we reduce the local concentration of carbon dioxide in the oceans in preparation for allowing more of that carbon dioxide to enter from the atmosphere, we will decrease the acidity in the process. That'll be localized and at a small scale, because one of the ways you can think about it is that it basically represents CDR potential. It represents it sort of occurs when there's this kind of lag in between the carbon capture in the oceans and subsequent carbon invasion from the atmosphere. But that's perhaps the largest sort of co-benefit. I'll also say that, especially for the sort of macroalgal pathway, that there's a lot of thought that you can do this in conjunction either with aquaculture operations, or that you can sort of develop permaculture style arrays so that you could increase potentially fish biomass and biodiversity in the vicinity of these operations.
Great. Thank you. Another aspect that came up in the chat here was the issue around commercialization and the dangers and opportunities from commercialization. We all know that things that have commercial value and energy tend to be scalable fairly quickly. And we've seen that in enterprises, from the smartphone to Airbnb to, you name it. You pick your thing that's scaled quickly across the globe. But yet a lot of people are very concerned about anything that has a commercial aspect to it. Will, anything you see in out there as an analog for how we might be able to really foster commercialization here while making sure that it doesn't somehow become a very bad thing?
Right. Well, if you look at the clean development mechanism under the Kyoto Protocol, for example, it's a fairly good analog where rules were developed to allow for carbon credits to be obtained under the mechanism, and ultimately you had a large number of actors that were able to avail themselves of those, start building both small-based and large-based projects, some of the small-based projects being aggregated, and developing a fairly viable market. And I think the same can be done here. I think the challenge is, and it's something that needs to be emphasized, is that we still need a lot of characterization in terms of the potential for a lot of these things. Ocean iron fertilization is a perfect example. When it was initially being discussed, there were claims that we could sequester 25% of the world's CO2 with ocean iron fertilization. And as we started doing the experiments, we started finding out there was substantial remineralization. We found out that there was lots of consumption of the phytoplankton that were produced at surface, and almost all the CO2 then released well above the thermocline, where it would have to go to be sequestered, or below. And so we wouldn't have wanted to allow the claiming of commercial credits at the outset with that, because the market would have quickly lost credibility, right? And so doing the experiments, characterizing, determining that approach probably isn't that viable, and moving on is part of what we need. And that's why it's important to have regimes at the outset that say you can't immediately obtain carbon credits, but if you can prove their viability, then we could move forward. And so we do have climate-based markets, both voluntary carbon markets and the institutional markets, such as under Kyoto, that would provide us with a framework for moving forward ultimately.
Yeah, excellent. That's really helpful. I think one of the things we're finding, and I just want to mention that Ocean Visions is doing what we call a technology road mapping exercise here to identify for 3 big domains of ocean carbon dioxide removal that Dave referred to. What are the 1-year, 3-year, and 5-year steps that are going to be necessary, the obstacles to overcome, the first order questions to answer, the stage gates to go through in order to see whether these things scale. And, so for those of you who are interested in continuing and being engaged and looking for what those next steps are, please visit oceanvisions.org or reach out to Dave or myself, and we will help you get engaged. I think, there is going to be, one of the things we're looking at in that effort are commercializable technologies, because we don't think we're going to be able to move quickly enough just with public funding or voluntary carbon markets. And so 2 of those pathways, the macroalgae and the electrochemical pathway, both have very viable co-products that come out of them potentially, that actually make the carbon and a benefit that you don't have to build the entire commercial enterprise on the carbon alone. The third one of ocean alkalinization, as of yet, it's not clear what what those co-products might be. We are 5 minutes from the close, and I just wanted to give each of you a 1-minute chance to make any last comments and closing remarks. And Brad Warren, I'll start with you. Please keep it to 1 minute if you can, if you will. And Brad, you're off camera and off mute, so maybe I'll go with you.
I am off camera. I can talk to you though. I would say a key message for us is let's make sure we talk to the people who live on and depend on the ocean, so we get them built into this solution, not paved over by it.
Okay, thank you. That was succinct. Will.
Yeah. My comments are probably fairly consistent with those of Brad. I think on the legal side, one of the things that's really important is to engage with key actors, especially in the global South, on these issues. If we're going to incorporate this as a broad scale response to climate change, especially within the Paris Agreement, we're going to have to get countries in the South to agree that it's an important and necessary part of the process. And if we simply try to foist it off upon them, we're going to get the same kind of backlash that we often do when we look at anything other than traditional mitigation.
Thank you. Dave.
I just want to say that, it's really exciting to see this many people on the call, and a lot of you are familiar with the fact that many of the ideas that we've talked about have been demoed at benchtop scale, have been demoed in models, but we really need to get to the point where we're having small, controlled, transparent, proof of concept field experiments so that we can evaluate transparently, openly, and in international coordination frameworks, the co-benefits and the disbenefits of these various pathways so that we can do this in an equitable manner and make well-informed decisions about whether or not this is a viable set of options for carbon dioxide removal moving forward.
Great. So just a couple last thoughts from me, and I'll turn it back to Jason to close. I think you all are part of a CDR community. That's why you're part of AirMiners, and that's why you're showing up. And so we don't have to, I don't think we have to make the case for CDR. I think we do want to make the case that the oceans have enormous potential. And we're going to need a lot of work accelerated and intensified and expanded to really determine just how much potential, just how many co-benefits, and just how many disbenefits. But from what we know today, this is very viable territory for increased and accelerated research, testing, and development. And as Dave said, very quickly getting into proofs of concept in the water so that we can really understand where this field goes next. And we all say it's an emergency. We have to wake up every day and act accordingly, like it truly is an emergency, and not look backwards at what we did over the past 25 or 30 years, but look at what we're going to do differently over the next. So thank you very much. And thank you, Jason. Thank you, Jason, and thank you, Tito. And I will stop there.
All right. Thank you, Brad, for an excellent job moderating today, and Brad Warren and Dave and Will for panelists. And thank you all for coming as well. That's the conclusion of our program today. Tito had shared the post-event survey for you to take. We'd love to hear any and all feedback, good, bad, indifferent. We want to hear it so that we can improve for future. Also, I shared some more links for further actions on oceans, noting that a future event will dive a little bit deeper, haha, pun, into a little bit about organizations and businesses and entrepreneurs who are implementing business models here. This is the conclusion of our program. Take a look for future events on our AirMiners events emails. And we're going to hang around here for another 15 or 20 minutes after the top of the hour so that we can break into Zoom breakout rooms and have in-group networking so that we can get to know each other and not just know of each other. Other than that, this has been fantastic, and I hope you found so as well. Thank you, everyone.